All right, Kat, roll us in.
Welcome, lads and ladettes, to Aether Roundtable number 95, Analyzing the Celestial Sheets. Alan and Shane, take it away.
All right, hello and welcome, everyone. Thank you for joining us on this very special episode of the Celestial Sheets Editing Edition. We're going to go over the spreadsheet, and I think we're going to plot some data out, make another sheet to make graphs with. Shane's going to lend us his expertise and guide us through the process here to add to the spreadsheet so we can turn this amalgamation of calculations into something that somebody could look at and immediately identify, oh, this makes sense, this doesn't make sense. So hopefully we have a nice smooth process here, and every time we do a function or a column, it works out flawlessly and there's no, it's a one tap every time.
Excellent. That's never happened to me once, but today will definitely be that day.
Do it live, as they say.
I love the confidence. Nice. So you want to start sharing? You want to walk you through it? We can do it on Google Sheets.
Oh, yeah. I thought I was sharing already. Sorry. Here you go. And then you should probably also share, and then I could look at what you're doing on the side.
Also share now.
What's up, Gally?
And then Gally, if you could get a screen share in of us screen sharing, that way we can keep an eye on the whole situation. We can get a nice overview. And also, quick shout out to everyone who's contributed to the spread. Oh, 1 second, I'm echoing. Someone's echoing me. Gally.
Gally out.
It's echoing. Gally. Shout out to everyone that has contributed and helped out to the spreadsheet and given advice and fix things and help patch things up. You guys are awesome. We're going to have a nice, clean sheet when this is done. Some say we will have the cleanest celestial sheet ever produced. I'll say that.
I say
Nice.
that.
Gally, did you eat food and then come on Discord to talk?
Yes.
Respect. All right. Let's get to the celestial sheet here. So Shane has his screen up,
Right.
So we can have a little tutorial.
Yeah, first thing I did is just make a new tab, right? I'm going to use it's going to be the one we're going to graph on. And then all I did was take the mountains and the stars, right? So we have these two combinations are the same combinations you can get within your table, but we're going to show the data that we want to graph. So I think the first one you want to do is probably difference from predicted elevation as one flat metric, right? So we probably put the Pikes Peak elevation somewhere, and then we need to get from that the difference between the final globe prediction and its actual height, right? So essentially on your table, it's probably what's a delta globe something right over here, globe observer distance and globe observer height right here. So these two. Grab this one. This is Pikes Peak, right? No, it's not. Doesn't matter. I think mine's still set up for VLOOKUP. I didn't get your index adjustment, but that's okay. That works the same. So this right here, this is the...
Do you want me to send you a fresh copy?
No, I think I could just download it. I just haven't. I should probably do that. But all the data is the same, so I don't think it matters for this.
Yeah.
We're just trying to get to the...
So you said I just need delta alt, and what else?
Yeah, so whatever other one we want to compare. So which globe is this one again, this color?
Let's see.
Is this Heffron globe? Or?
No, you want to go down to Mu globe. And the numbers you want are for the 180 drop. So you want the one that corresponds to 217 there. And then let's see. So you want 202. You want
this one.
This one. Yeah, you want the 202, and then you want the one under that for distance for raw globe.
Okay. All right. Elevation globe. So yeah, whatever one this is Mu globe, as he called it. We'll call it that over here. This is what we're going to be graphing. So Mu globe difference in elevation. Probably got to do distance over here. So then we would need the one below it. Now, because we only have one sheet, we're not gonna like cell link all these values. We're just gonna set up a new table with flat values. So what I've been doing is just copying values only. So I'm grabbing this distance and I'm just putting it as a single value over here, right? If you don't do it, it gives you that. If you do paste value, it gives you this. So then we have just our values because we don't need to do any more formulas over here. All the things that we need are already neatly calculated. So we're just going to grab them from your calculator table and put them in a cohesive place so we can chart them out with a graph.
1 sec, doing the same to my spreadsheet. We're just doing the actual difference, right? We're not doing like
Yep.
what it
The
was.
final number, the only final result. Yeah.
Gotcha. Right. Actually, I can just copy the whole thing, couldn't I?
And then we want to do that with probably all the globe
Yep.
variables. So let's see. What's the other one? What's this one?
Uh,
Aries globe?
Aries globe. I'd have to see the color. Okay,
Purple?
that's gamma refracted. That's the refracted globe. So that's terrestrial refraction globe.
Gamma
That's
reflector?
that's raw globe plus terrestrial refraction.
Raw globe plus. Yeah, okay, whatever. And this is really, why does it look the same? Oh, it's Y. Okay. Should probably make it the same color. There you go. So I know what that is. And then we need the same two values. So 172 is the alt, and then distance. There you go. Think like this. Yeah. If you look at Heffron, see it says set up very similarly. Can you see my other spreadsheet, or is it only showing this one? Here, let's change this to screen. There we go. You can see Heffron's sheet
Yeah.
has it set up very similarly, right? I would pretty much do this. He's got it set up in columns so we can just drag, but we're gonna do this manually. So star, date, or whatever, he's got his two. We got peak and mountain, and then he's got, his flat Earth delta, his globe Earth, and his globe Earth refracted. We're gonna do similar, except with all the stuff that you have. Well, we need to make an actual table, so we're not going to use the list menu. You're not using that, are you? The index function still?
Yeah. I just copied that over. I can just delete that, right?
Yeah, I'm probably not gonna use it for the graph. You can do something in graph called pivot graph, which is when from the data you create, you can also further pivot it and aggregate it, and you can do what that will do inside the graph itself. But to graph the data, you want it just by itself and isolated,
So
not accessible within that table. So you want to just make you have the two columns, right?
yeah, so I can't even change this.
Yeah, because you copied it over as itself. So you want to just delete those two cells and probably just make a column of peaks, probably just peaks and stars, maybe. You could even do like peaks and then just use one star from every peak. I don't know if you need to use multiple stars from each peak. It's up to you.
Nah, just to start the baseline, we can just do one per each.
Yeah, that's what I think is probably easier.
All right. So we can do peak and star. And what was it? 39 Aquarii.
Yep.
All right, I think I fixed it for the most part. Should be good to go. My table looks very similar to yours.
Well, you don't need any of the stuff below there, right? Like, because all we need
Below
is we're
what?
going to go on the right. Like, because you have all the other stuff like distance, UTC, observer, peak lat. You're not going to need any of that below in the gray. Oh, you just copied all that? You're not going to use any of that, right?
I just copied it in case you need it.
Oh, gotcha.
So all we needed though was just peak and thing, right?
Yeah.
Then?
Yeah.
I see. Okay. Well, you know what?
Yep.
Go ahead and delete and never met her.
So that means that wait, what's this one? Is this one Pikes Peak? This one is negative for the. Oh, they're all negative for the elevation. No, for the distance. What is this? For distance.
It's how much they're off, but it just displays it as that way.
Oh,
They're all positive.
okay. So that then.
I'll fix that later. All right.
There you go. So I got raw globe, and what's the orange one? You got Aries globe. What's this one again? Refracted globe.
Yeah, so that's just adding the celestial refraction to the raw prediction to see if it closely matches what the
I thought it was
prediction
the Heffron
was.
method.
No,
Oh, that's you.
it is, but that's not part of the distance analysis stuff. That's just supplementary comparisons for things. All you need down here is the 180 distance stuff. So that's the Heffron one.
The Heffron globe.
Yes.
Right. Okay.
Mm-hmm.
We'll put that over here. Next
And
one.
then another one that you might want would be epsilon globe. That would be the
Red one.
That would be the apparent position at observer locations, like the one that they always want to talk about, but never do any distances off of.
Yeah, I guess we should include that one, even though it gives it the appearance of validity to include it.
It's the yeah.
Is that this super red one then? This one up here?
Yes. Yeah, that's epsilon. Yeah.
Got it.
Yeah, I changed them in the recent update, so it's you can more easily tell the difference between what they all are.
Okay. Probably could have grabbed that then. It's fine.
But
You
yeah.
did make it nice. And then this one. All right. There we go. All right. So now all my columns are set up, and now I have most of my data. Now I need to get it for all the peaks. So that's what we need from each sheet, essentially, is the elevation and the distance for each prediction. Oh, we need the flat Earth prediction too, obviously. Put that first. What did you call it? True Earth? Oh, you called it flat. Okay. Elevation and distance. So all we're graphing and comparing then is the final trigonometric formula when we're using the final angle, like for Pikes Peak, 219 versus 232. And what we're doing that is basically divided by the tangent to get the true elevation and the true distance, having a triangle constructed using that angle. And then we're going to graph the distance between all of the triangles created by all of the globular methods for this one observation.
Globular methods.
Yeah, I think because it's funny that they need 7 different methods, but there is no singular method that's consistently better across all the peaks. They just get to pick and choose depending on the distance and elevation ratio, whether the arc length or the 360 pi r or over 2d squared or whatever one happens to work for this particular scenario, then they get to choose. That's like maximum benefit of the doubt.
Yeah.
36. So this is -2. Should I keep the negatives then? Is this 36 feet too low? Is that what it says?
No, so our predicted angle was 31. The occlusion angle was 33. So
This is for the elevation from our angle.
yeah,
30, negative 36 meters.
No, it's the difference in our prediction versus what was measured. So we predicted 31, it was occluded at 33. So we're off by 30 meters, but it was because it was higher. So you could just treat them all as positive.
I can just use absolute value. Okay,
Yeah.
cool.
And then actually somebody just sent me a thing that they were calculating all the distances to everything using movable types, and the distance on Pikes Peak they got was 50,550. and that makes it even a little closer. It gets us 29 meters off instead of 39 and 666 meters off in distance.
Nice.
That's pretty funny. It gave us like 200 meters in as a boost. Globe still significantly devastated, obviously.
All right, and then I need my Heffron method, which is, where's your distance? This thing's 202. No, it doesn't sound right. 232. It's at 202. That's free. Versus 5,000. It's the same as this one? Okay. Maybe I got my oranges confused. All right. So like this is how mine's set up, is how the whole thing's gonna go. Right.
Yeah.
2 pairs of elevation and distance for each method, and then the method's just up top, and then we're gonna graph all these methods. So now all I've done is copy the data over for one Pike's Peak, and then we're gonna get all the other peaks.
Okay, 1 second.
And it might get messy. We might want to do one graph for distance and one for elevation. See how it looks with 7 different strands for each observation.
You don't like a cascading lightning graph or whatever? Okay.
Well, I mean, it could be. It could be fine. Let's see.
Check my screen. Am I doing it all right there? Delete that.
Yeah. Well, so the way you're gonna want it set up is just the name and then the data. So that middle column you have should be up top. Should be like a subheading for elevation and distance, so that you can tell that those 2 elevation and distances apply to that method. But it shouldn't be on the left-hand column because you're gonna have to grab sequential columns to do the graph.
Oh, I see what you did. You grouped them together like that.
Yep.
Okay, that makes sense. All right.
If you look at Heffron's graph, you kind of do the same thing. You set them up just like this. Like, notice how simple his little table is to produce this cool graph. 1 column, 2 column, 3 column. It's just one for each method. And we're already kind of making that more complicated by doing 6 methods.
All right. Well, I'm only doing his method, apparent, and flat earth angle, like raw flat earth angle.
The way we can set it up is that we can actively turn on and off any of these with like little buttons once we're done. So we can do like just Heffron method. Okay, just this globe. Okay, how's whatever.
Perfect. All right. All right.
What up, Ken? Oops, Teddick. You guys hanging out with us, watching Spreadsheet Wars?
Watching the Wars of the Sheets.
Oh yeah. Trying to learn as much as I can. Hell, I got Mortar One and Ruhif coming at me.
Yeah. Notice that they ignore us and go right for you. So it's so weird. They're like, shut up, Shane. Ken, what do you think? Ken, what did you see? Yeah, that's a good strategy.
If you can't steal man, it must not be true or whatever.
Yep.
I'm finished eating, but I can get some more food if you want me to comment on stuff.
Yes.
Yeah, only with a mouthful. Thanks. Yeah. All right, I'm gonna go through and grab all the other data for all the stuff now. I think.
Yeah, you do your
change.
you do your thing. I'm gonna
plot at peak.
I'm gonna slowly mimic what you did.
Okay, and it's LP acquired to choose. Okay, cool. Rinse and repeat. Oh no, what did I do? All right, you know what? Give me a new spreadsheet. I want the index function.
Yeah, it's too good, huh?
There
you go.
Yep, thank you.
should be in the. That should be it.
Cool. All right. Let me just take this one, open it up, grab this new table, change this over to main.
Wait, that's not it. It's this one.
How dare you? Jeez. You can tell the difference between those two? Okay, cool. All right. Like, oh no, I sent you the wrong double timestamp 0001 parentheses 1.
Oh, wait. Okay, wait. Strike that. It was the right one the whole time.
All right. So now I can do, what is this? Why is it protected? Protected view, enable saving. There we go. So now I can just take your sheet and move over to my sheet by doing this. Bloop, bloop. There you go. Now I can delete this one. And now I have your main function, which is cool. All right, so I can continue doing this. Hey.
All right, so what we're gonna do this episode is we're gonna watch you edit this, and then I'm gonna reproduce this all later so I can learn it so that it looks cohesive when you're doing it. So I'm much slower than you. You're doing great, kid.
This whole thing didn't work. This is not a list now.
Oh, what happened?
I don't know. But now I gotta undo what I just did. Oh man. All right, let me open up the old one. Probably should have checked to see if it works first. See, it doesn't. Oh, there it goes. Now it does. Cool. All right, so we need the next one. Oh no, this is mine still. Also yours. All right, cool. Give me the first one you sent. There we go. See, is it me or this is still a VLOOKUP? Well, Logic Peak.
It doesn't look like it's working correctly though.
Nope, it is not.
Why is it not working right? Is it the translation from Google Sheets to Excel?
Yeah. Oh, here, I'll just do this. I had yours. Oh, crap. Sheets. I had yours pulled up. There we go. No, it's not it. Do this one. All right. We can just do this. Logic Peak and oh my God. Menu filter guide. What happened? Oh, I got it right here. Download. I wonder if you were the problem.
Like I
Like
said,
when you-
we're gonna one tap this right off the bat. Every time. Everything's gonna work immediately. What did I do wrong? Do you want the old one that has like the separate sheets? I can give you one of those bad boys.
No, I think it's fine.
Oh, that's
No,
working
it broke.
now. Oh,
Nope.
what the rug?
Oh, it's supposed to be. Is it the same star?
Blackjack Peak is LP Aquarii.
Yeah, that's what I
Pikes
thought.
Peak is 39.
I'm trying to do Blodgett Peak to get some values. Yeah, just send me the old one so I can get the actual.
Yeah.
Pikes Peak worked, so it gave the appearance of working. Huh. And then I go to Blodgett Peak. You know what? I'll just skip Blodgett Peak. We'll go to Cheyenne Mountain. It's just Cheyenne Mountain work with Moon.
I sent you the backup of the old one that has them in separate sheets.
You know what? It's just Blodgett Peak that's fucked up, so we'll just skip that one for now. It's cool. No big deal. Let's see if we can do this so we can do it quickly. Can we see both?
Yes, sir.
All right. And then here's the table. All right, cool. You freeze frame. Fix frames. Okay, cool. So now we can look for it. So for Cheyenne, we're looking for flat difference 36 and difference 3600. We need globe. We need orange. So that's this one over here. All right, 142. Base 143 and 9,000 different miles. Okay.
You copied those into the Pikes Peak columns.
Sure did. We're going here.
Is that a ref column on purpose, Shane?
No, that's a real ref problem when I didn't do paste correctly. Right? If you don't do paste correctly, let's see. Blood. That's actually Pikes Peak, 39 Aquari. And that was which Mew? Which orange is this? What is Aries globe? This one.
The raw globe for Heffron method is Aries globe Mu.
202. Paste values. There you go. So that's fixed. Back to this mountain. Maybe we'll just do a couple of these so it doesn't get super boring, and then we can get a graph going. Cheyenne, LP. There we go. So we got this is distance. No, this is elevation. Distance is this. Yeah. One of these. 142. We already got that. 9,000 kilometers wrong. Okay. And flat was 79. Yeah, we did that. Purple globe. That's one, I bet. Paste values, paste values. We want just positive values. Okay. Swing and a miss. Yeah, that's okay. Moving up one. Okay. Heffron method. So this one gives you 142 and 9,000. All right. Red globe, super red globe, which is this one. 15 off. Is that right? Yeah. 5,000.
Yeah, red globe is refracted at observer location, celestial refraction only.
All right, so get rid of negatives. Cool. Get rid of your negative. And just for fun, we'll make them all the same style, same decimal places. There we go. And now let's try pivot graph. So we go insert, chart. Let's see what it recommends first. No. Line probably. That looks good. Difference in elevation. I like that for a basic differentiation structure. Can also do this flat baseline. Cool thing is once we do this, we can change it at literally any point. We can just reformat it, restructure it. But I think this for a start is good. This over here, maybe this over here. I like that.
What's the scatter graph looking like by comparison?
Insert recommended chart, all chart, scatter. We got. Is this what Stone used?
Yeah, Stone's preferential to the scatter, I think.
Yeah, but we need
and also a line one. So like
yep.
If you go over one, I think that one right there.
Yeah, that's definitely useful with more and more data points. Not so useful with the two that we got right now. Had it. Right. But once we have it, we can definitely.
I plotted that two piece where I was having.
Yeah, well, I just wanted to format it. Yeah, you want to scatter two piece. So we can do, we'll name it. So what do we call it tonight? what was the name of
Celestial
spreads? Celestial sheet comparison. There you go. And we can do all sorts of formatting stuff, but to quickly do what we did before, to give it a color palette, right? It's just a chart design, and we give it one of these, make it pop, maybe. So then now we have, once we have our data sets, we'll see the difference, and we can set the range, like we want it popping up at 10,000, maybe not. Maybe we want it only at, we want to make it shorter. So there you go, we do that.
There you
Pop
go.
that out. So now we got some comparison. And so now we got to add the rest of our data, and we'll pop out our graph as we're comparing. The other thing is we got elevation and distance each time. We should probably separate that maybe.
Yeah, it's a little confusing to read.
I thought it might be. So we should name this distance graph, and then and then we can change what we do to change the data set. There we go. Select data, and we only use distance like this. Boom. So this one will be distance, and we'll remove all the elevation. So nice and easy. Now we get distance comparisons.
Nice.
Wrong.
Ooh, that's clean, dog.
It's looking good.
Oh, I can't wait to do this later.
Now we'll do this one for elevation.
This is going to be so fun.
Elevation. Yeah, so this is what I was doing with Mike's data for a while, just making it like graphing differently. So there's distance, and we want to change this to actually be the other inverse. So change data. We want elevation. So let's select that. Cool. And we want to change this to this, probably less. There you go. And up to 250. All right, cool.
What did you change there?
I did the semi-major axis. I did it so the bounds was set to a much lower, so it would focus on this. It was doing a peak elevation at 6,000 meters, and the difference between 0 and 200 got lost in there. That's why it looked like a line.
Yeah, gotcha.
So we just expanded that out. So now we got our distance and we got our elevation. So this is elevation. That'd be distance. All right, cool. So now we just got to add more data.
And so we're supposed to be closer to 0 on those, right?
Yeah. So the thing about the elevation is that anything above 0 is wrong. So we can probably plot a 0 line, or we focus it so that 0 is more visible. We can do -5, something like this. So 0 is actually over here. And then we can increment it by 10 so that we can get a grid line so you can see. And then you can even add data labels to it so we can see the elevation at which it is. Nice. So there we go.
Nice.
So now we know what we're looking at. And this will be a color code down here. But again, we got to get more data for the rest of them. So we got Pikes Peak and Cheyenne. So let's do Mount Rosa quick. All right, up here. And what does Mount Rosa look at? HD 17320. Cool. All right. So flat. Off. Just fixing this a little bit. There we go. Now I can see paste values. That's not what I wanted to do though. Mount Rosa, right? Yeah. Paste. All right. And then flat distance prediction is only off 163 meters, huh? Mount Rosa is a slam dunk. It's amazing.
Yeah, it's nuts, dog.
Crap, I just overwrote Cheyenne.
They're pretty much all slam dunks except for one of the Mount Blend ones where it's ambiguous because the refracted position is equal to the true position at the mountain.
Yep. Happens a lot. I wonder why they chose that.
Yeah. Yeah, it's really interesting what that analysis shows, because it's just like the only time they could get it to do that is when that works and their emergence time. So think about this, man. the emergence didn't occur until the true position was within 4 arc seconds of the peak. And
Arc minutes.
yeah, sorry, arc minutes. And then their whole position is that's irrelevant. Refraction is like a 1-to-1 correction ratio. So the star should have emerged way sooner than what the flat Earth timing predicted. I mean, their refracted angle is our raw flat Earth position. Like that's insane.
Within 4 arc minutes, huh?
Yep.
And that's a victory? No.
Yep.
That's indistinguishable.
Indistinguishable.
We don't want negative. We don't want negatives. Cool. That's a negative. All right. So now we just need Heffron method for comparison, which I think is this one, right? Yeah, 179 and 6,800. And red one. Putting the red one up here. This is super refracted globe.
This is celestial refracted observer position.
Yikes. Okay. All right. Now I just want to see if I do this. So look, it already appeared. Boom. And boom.
Here.
So we're rocking.
Oh, it just swoops them both in there, huh?
Yep.
And you just change the color to the corresponding method.
Nope. It already picks that up automatically, but we do want to make sure all of these are in the same format so that it stops looking so goofy. There we go. And then now it looks fine. All right, cool.
Yeah, it was looking a little goofy there. Nice. Yeah, it looks awesome.
Cool. So we can do this going and then we'll compare it. So where's our flat one? We got to get our flat comparison. Was flat a mountain? I think we made flat a mountain. Oh no, we made it a method. Okay. So we got to name the series better.
Yeah, it's hard to tell.
Huh. There we go. Right, there we go. So I named it wrong. I named it by the peaks, but we'll have to change these real quick so that it actually names the series, the title that we used.
That was
and then we'll be able to tell.
That was super confusing.
Yeah. So this needs to go over here so that this needs to become this. And this needs to become this. And you are actually this. Let's see this.
Nice. You can see I cleaned it up.
Yep.
Didn't change the graph color though.
No, so I didn't populate data in these series down here. Each one of these is a series. That's what it's graphing. That's why we set it up like this. So for Mount Rosa, we have all of these different methods showing our different elevation predictions.
Oh, okay. So the colors correspond to the peak per graph.
Yeah.
Okay, gotcha.
Yeah, which is what we're trying to change because I want to make it the same color as this. So now this is the method.
I see.
And then this is the distance. So then we need to flip it for the peak, I think. So nice and easy. We're only using the distance here. So new globe. Yeah. Which one do we fill out? This one.
Oh man, I had no idea it was like this easy. Well, I kind of did because Stone showed me, but like going over it again is definitely.
So this is, I think, a good start for what we want to do. We just got to fill out the rest of this data with specific differences in elevation and distance. We can also, like, what else do you want to grab? We're doing a bunch.
So I would like to do lift over drop, celestial refraction lift over drop
Over here.
Mm-hmm. So like
these two
expected glow. No, just go up real quick. Column, because you can't pull anything from those. Those are individual housed things. Right. You got to go up to 178 there. column E8, I think it is, globe drop. E9 maybe? Yeah, E10, sorry. So there's our globe drop in meters. And then if you go down to the very bottom, you'll see column E71, I think that is. Right there. Go up 170. That's the lifted meters. So E71.
So these two.
Yep.
That's easy enough. And then that's per star per thing. So we would do this bracket lift. We would add probably over here. And we'd use the same table, but we'd graph differently. So I'd probably put that over here. Let's see. The other one is this. Put that over here.
Oh, sorry, I have my mic muted. So once you set up the series, you can just keep graphing stuff to the same exact page. I mean, you can put any data to the same page and just map it all from there.
Yeah, what I usually do is make different copies. Like you, I immediately just like right click copy and made it this one, so you have distance and just separate from elevation. But you can do that unlimited number of times, and you really should. Like I'm making that same mistake that you did. Graphs. We should really just make one and graph. I'll get all the data in and.
Okay, how do I do?
Start making copies.
Yeah, how do we do it the correct way? Because I don't want to have to redo it.
We want to fill this out.
Okay.
Completely correctly first, and then like we even add this other metric. Anything that we want to graph, put in the table.
Yeah, I'll consolidate it to the sheet that we have our series on. Right.
Yep. And then from there, we can make unlimited number of these and any different permutations, different styles. You can make one with line. You can change it. And then this becomes a dynamic graph. We can do called a pivot graph, which is essentially a pivot table, but in graph form. We can pick and choose any of these as we go. It's this one, insert pivot graph. Pivot chart. There we go. Pivot chart and pivot table. And then you get stuff like this, where we can actually in live time pop it off and drop it, like change this. This whole style can be changed to a different type, etc. We can do the difference on the fly. Right, so that's cool. Pivot graph is a little bit different, but that'll be useful when we have all the data in pulled from all the different peaks. I mean, it would be one thing to use this, but this is all the actual data. This isn't any comparison.
Right.
Raw data, observations, and then this will be the raw empirical calculated differences based on everything you have in everything over here. This is super neat to do in one sheet, but we need all the different peaks data separately. It wouldn't have made it any easier. We still would have to go grab it individually.
and I don't even mind it like that, because anything that we add to the sheet, we only have to do it once, and then we just copy it to the other one for the graph, and we're done.
Yep.
And then we just do that for every peak and star. That would be annoying, but that's the consequences of owning hard. Sometimes you gotta grind. But that's but even that's way better than redoing multiple like, oh my god, I can't even imagine doing graphs off of what we had before and then updating something. Oh no.
Yep. It would be super hard. So then once you put all of it in this table, then we can have this nice pivot graph or pivot chart that we can, like I said, add and drop things. Like, oh, we don't want distance, we want elevation. We want this second elevation or whatever we have, right? Because we named it weird. We can swap what's on this side versus what's on this side. So we can do distance down here. We can do, we can put it any which way we want, and it'll make it very easy. Like, what do we want as a series? What do we want as a value? And we can switch it all around. So that'll be where we end up with it, so that we can analyze on the fly, and then we'll get good with it, I think. But fill this out in the meantime, and then we'll go from there. Spreadsheet wars, dude.
The war of the spreadsheets, the war of the celestial sheets.
Yeah, it should be said that other sheets floating around are comparing different values. Like, they're not using true occlusion times, they're using from an observer and comparing what's known as apples to oranges.
Yeah, in other words, not doing the method at all, or adhering to any of the methodology analysis that corresponds to the actual method.
Yeah, I'm going to do a completely different method and then call it your method and then use that to debunk your method. Very misleading.
The classic switch and bait.
Oh, see, this still has all your old analysis from before. You removed all this already.
Well, I just moved it out of the way. And
you
then
put it down here.
yeah, just further down because it makes that one tab pop out, or it did before earlier. Anyway, doesn't matter.
Nice. Always a work in progress
But
from
yeah,
the community.
so with the graphs, right? What we could do is show the differences, all plotted out, and then also include like air tolerance margins. So it's like if any distance passes this threshold, the measurement goes, then it's clearly in one direction, right? Like we could set up all kinds of stuff for the graph.
Yes, anything you want. And like I said, the only problem you're gonna find is the ways to compare it.
Yeah.
Like, oh, I thought about doing this versus this, or how do I want to do, of all the observations on Pikes Peak, which one, did this, or of all the elevation gauges, which one does this, or super easy. Once you get this rocking with all the stuff, like I said, it'll be super easy. And then you can change this at any point.
That's awesome.
We don't want sum of distance. We want sum of elevation. We want 2 elevations. Yeah, pivot charts are really cool. I don't get to use them very much, but like I said, Heffron's chart is very simple, but he uses all the same things. Notice he's got the charts over here. He made it with a correction so we can turn stuff on and off, right? The data changes like this. If we do on versus off, right? The J factor gets put on and off. Corrected bit to globe perfect azimuth. All the data shifts. It just moves closer to 0. By adjusting the globe prediction closer to perfect globe, it inadvertently straightens out all of flat Earth predictions to within 5 meters or so. Right? That's not a fudge factor. That's a data aggregation cleanup tool. If this is the raw data that we start with, and because again, the reason he did that was people were like, it's too inconsistent to be valid. If it was valid, all the flat Earth would be. Why is it off even a little bit? Right? Now, that's what they said. So he was like, okay, I see what you're saying. I'll go ahead and add this. And look what happened. Cleaned it right up. And they were like, now you've added a fudge factor to make flat Earth right all. That was the progression of the grid. And that's where the J factor came from.
I had no idea what the comparison thing like truly was, like in regards to that. Like it made sense on paper to say it, but like and articulate it. But it wasn't until I went and tried to make my own spreadsheet that I was like, oh, I need an ideal globe to compare to though to see how much everything's off. And it was like, how doth one computate the ideal globe? And it was like, well, we need our terrestrial refraction, we need our celestial refraction, we need to move the observer here, we need to move him there, we need to reference where it once was on the vernal equinox. I'm like, all right, dude, I don't know, I'll add all of them and we'll see what happens.
Yep, I like the method because it can't go wrong. You're like, listen, you guys are gonna keep changing all this stuff. If every time you're wrong, you're actually not. We're just doing it wrong. Then how am I going to combat that?
Dude, we're doing our own method wrong while simultaneously deriving our distance using just the same angle. And whereas theirs requires like special refractions that require you to know your distance so that it could first apply the amount of refraction to it, like all these ridiculous things.
Yep.
We just doing a simple plain trick, just the old tangy.
Which gets lost in the sauce, I think. People are like, you need all these fudge factors and stellarium, and it's like, no. What we need is arctan rise over run. Period. That's it. This guy's got so complicated with it that you think we need all the shit that you said that you need when you're shit. Every time the globe was off, they were like, the globe isn't wrong. You know what happened? You're doing it wrong. And that happens 7 times, so that there's 7 different methods over here, so that we have all these different methods to calculate globe whenever it's like, that's amazing. So I'm glad you're keeping track of every different incorrect method that the model can't be saved with.
Dude, if they won't steelman themselves, I'll have to do it for them.
But then they can't claim that we can't steelman them anymore, because right now they just claim that it's a straw man and that we don't know what the. But the truth is, ladies and gentlemen, they don't know what the globe is, and they don't agree on it at any given point. If Jesse, the prediction is different than Ruhif's, which is different than Stellarium, which is different than Arctic, like, who's the correct globe prediction? Who's to say in that situation?
The globular arbiter. That's why I choose our librarian or whatever for help with that stuff.
That's why Heffron's method is king, because he uses a, like, I guess not a third party arbiter, but at least a way to corroborate the globular proponent's measurement. So you can't say we're straw manning it if every time we predict for the globe, that globular prediction lines up with what Stellarium predicts for the globe. That's where we went with it. So we don't need to ask Jesse, and we don't need to declare Ruhif king of the globers to use all of Ruhif's measurements. No, our prediction is consistent with Stellarium. That's why we're still using it. Only the globe needs to change every single time whenever it's not right.
He said, I'm king of the globe. You can consult me for all globular measurements.
That's what he said when I was like, Ruhif, who am I to believe? He was like, me. And I was like, oh, okay. I guess that answers that question. Like, obviously, that's retarded.
But
I
anyway.
totally remember that. That was crazy.
Yeah, that was pretty funny. Good times.
Hey, I have a quick question. Is that okay?
What's up, Lily?
Of course.
Well, I was going to say, if refraction didn't play any role in the star, when it was still on Dr. Heffron's side of the peak, and then he only just noted down the exact second when the star became occluded, then why are they trying to use refraction once the star was on the other side from Dr. Heffron? I mean, they should both have equal observation, right?
Yeah,
am I not understanding?
No, so what they want to do, Lily, is confine it to the optical angular analysis. And optically, from Mike's place to the mountain, they predict 217, but with terrestrial refraction 219. So they're trying to make it just match with the apparent position and go, look, it occluded when we predict, but they're ignoring the fact that it occluded when the true position, which is the light source, calculated, at 15 degrees per hour with respect to where it once was, et cetera, et cetera. It didn't get occluded until that light source was intersected by the peak at 231 with respect to the peak's location. So they're ignoring half of the occlusion process, confining it to the angular analysis, and completely ignoring the fact that we could derive the elevation to the peak and also the distance to our location more closely than they can when using just one of the control or the independent variable and the dependent variable from the occlusion timing. Like they completely gloss over that, act like that's irrelevant, that's rubbish. Like suddenly finding your position on Earth with the stars is rubbish. That's a cool story.
The progression of this has been interesting to watch. From, oh, it's great, I love it. You guys we always ask for measurements, and I'm going to look through this and I'm going to find out why it's going to be great, and everyone's genial and everyone's friends. And then it went to, oh, well, you're actually straw manning how much globe drop should be representing these small angles. And then it went from, well, actually, you're doing the wrong drop distance with 60 over 2 pi r is actually not right. You want to use r squared over 2dr, and you're like, oh, okay. And then it became, well, no, you actually want to do 1 minus 2 over dr squared because that's the. And then that was, and then they were like, actually, you really ought to use at 2.4 arc seconds per kilometer when you spread. Sorry.
Dude, your mic is having a rough time tonight, bro.
Yeah, it's cutting out every third word.
Oh shit!
Yeah,
it's almost like you're cursing.
Horrible. You got horrible right now.
No way, Galley's talking.
Dude, I got crackers so I could join the conversation.
Oh, the Galley.
That's our thing, right? We get a bunch of food, stuff our mouth, and then start talking to Galatrax 5 days in a row.
No idea what you're talking about.
Oh, I thought you had braces, Gally.
No, I'm just stuffing my face with crackers.
Eating some saltines?
They're Ritz.
Yeah.
How about now? Is that better?
Yes, sir. I mean, that sounds a little... Nope, that's you're good. No cutting out anymore.
I wish you guys would have said something.
I did.
Was it only bad then? Okay, cool.
No,
nice.
It's been bad for a hot minute. And then
I
had to say something a couple times.
Oh, okay. All right. I unplugged it and plugged it back in again.
Nice. Oh, the old plug in trick.
Yeah, the
Oh.
de facto tech help.
Nice.
You were understandable for the most part. Just a little. Yeah.
It sounded like a Jerry Springer episode when it was like that. And it just cuts out real quick, you know.
Yeah, it's like
You
you
know,
were cursing. You're getting censored.
You know what happened was my instance of static mic control got buried, so I had 7 instances open, so it was all auto correcting each other.
Yeah,
Yeah.
that'll do it.
Yep. Well, unless you want to get some more copy pasting done.
Oh, your mic auto corrected to infinity there. We didn't hear any of that.
Mine?
Yeah, all we heard was, well, copy paste, and then that's it.
Well, unless you want to copy paste some more values into the table, that's what I said.
Oh, dude, it did it again. But I think I understood what you said. You're ready to
Really?
wrap up, and we've concluded the tutorial on spreading of the sheets and what will be presented at the next Cell Theo update. We'll have some nice graphs for all of this data that we've accumulated.
That's what's up.
All right. Thank you for tuning in to this week of Ether Cosmology. Much appreciated. We'll see you guys on Friday for community Twitter space. We'll see what the lads and ladettes are up to. We may even do some clubhousing on Thursday. We'll see what's going on Thursday. But Sunday will be an exciting Globebusters episode where Shane will be continuing his celestial and terrestrial sphere series. So we'll get a nice rendition of the second part. Which one is this in the series?
I think that's
Shane?
the solid 2-sphere model pres where we go full into it.
Ooh, nice. We get into the old coordinate system transformation. We get into the backbone of Stellarium. So apparently all these ancient cultures, primarily the Chinese, figured out latitude and longitude way before everyone else. And then Ptolemy also wrote a book about it, but then everyone forgot how to use it until after the stuff that the Chinese did was lost. And then the Royal Society recovered it and presented Newtonian dynamics guised as a celestial sphere model that includes negative coordinates that plot the stars beneath your feet as a mutually exclusive proof that we live on a sphere. So that was a cool history rendition that happened.
It's really hard to steel man the mainstream position on the history there.
It's like they knew it was a sphere, but then they forgot. And then the Chinese were doing it.
Tough to parse, man.
And then we took their method and said it was a globe. Classic. All right. Well, see you guys later in the week. Thank you for tuning in.